All right, welcome. Thank you for coming this evening. Welcome to Coastal Studies Institute. My name's Reed Corbett. I'm the Executive Director here at CSI, and we're always excited to invite our community to our public presentations, and I'll get to Dr. Schlenker in just a moment. We were showing some of the events that we do have coming up, but I always like to introduce them to you. One of the things that we do have coming up next month, sort of a special edition of our Science on the Sound. We're partnering with the Outer Banks Visitors Bureau and Michael Bassanite down at the Pioneer Theater, and we're offering sort of this cool screening of a video called The Cigarette Surfboard. It's basically providing, it's a film that's sort of brings together an understanding of conservation of the ocean, about litter in the ocean. And so it's going to be a large event. I'm not explaining it very well, but look for this event. It'll be screened at the Pioneer Theater. I'm doing great. It'll be screened at the Pioneer Theater. It's free, but you'll need to register because there's only a limited number of seats. And so again, that's April 17th. We won't have an event here at CSI, but this will be at the Pioneer Theater. As always, we've got some other events that are taking place here at the Coastal Studies Institute, including guided tours this month, March 25th, so next week, and also on April 9th. Summer camp registration is open for your kids or grandkids, and save the date for our open house, which is May 17th, and so it'll be the afternoon, 12:30 to 4. On May 17th. So with that, I'll introduce our speaker this evening, Dr. Lela Schlenker. So thank you for being here, Lela. Lela's currently the Fisheries Liaison for the Kitty Hawk Wind, and she's been doing that for a couple years now. Lela leads outreach for the project for fishermen, state, regional, and federal fisheries managers in the North Carolina research community. By training, Lela is a fisheries ecologist with 15 years experience doing cooperative and collaborative research in the Gulf of Mexico, New England, Mid-Atlantic, and Southeast U.S. Lela holds a master's degree in fisheries science from Virginia Institute of Marine Sciences, just up the road, and a PhD in marine ecology from the University of Miami. So with that, thank you.
Thanks, Reed. So great to be with you here today. So I will be covering quite a bit of background on a variety of topics. If you can't tell from the title, we're going to talk about shrimp. We're going to talk about offshore wind. Hopefully I will make that connection for everyone. But my goal is to leave plenty of time for questions at the end. So there might be a couple things that I go through quickly, but hopefully get your questions ready and I'll be happy to answer anything you want to know. So thanks to Reed for kind of covering who I am. I'm going to go over that really quickly. I'm going to talk a little bit about what I do in my current role for Avangrid. And then we're going to get into shrimp. We're going to talk about greentails and what they're trying to tell us. I do want to also mention that this is work that I did when I was here at the Coastal Studies Institute as a postdoctoral researcher. So I was working with Dr. Jim Morley and Nadine Heck here. And we had a couple of great collaborators at Division of Marine Fisheries, Chris Rock and Jason Stewart. And then I will switch into offshore wind mode and we'll talk about the Kitty Hawk Wind Project with some kind of general background on offshore wind in the US. Okay, so as Reed already mentioned, this is sort of my education story. I've worked on all kinds of critters in all kinds of places, just kind of been really fishy for about the last 15 to 20 years. In addition to kind of those education milestones, I've had a lot of jobs in between those things, including here at CSI. Gotten to do everything from, lounging around in a boat full of codfish to looking at small freshwater fish and invertebrates in the Everglades in Florida. So, variety of experiences that have somehow all led me here to this. So for about the last year and a half, since I ended my time at the Coastal Studies Institute, I've been working for Avangrid and the Kitty Hawk Wind Project. So there's a lot of text up here. We don't have to go through all of it. But basically a lot of what I do is communication. So be it with state and federal management agencies, fishermen, the regional management councils, nonprofits, the general public, like I'm doing right now. And I work on policy, so offshore wind is still fairly new in the United States. You know, a lot of what we're talking about is planned projects rather than projects that are already built. So kind of crafting what are the policies around how we do that in terms of, you know, federal surveys that like to survey in those waters, fishermen, and how we compensate them for those projects, and thinking even internationally. The company that I work for has an international parent company. We have projects in Australia, the UK, Japan, so kind of trying to standardize those processes and procedures and make sure that fishermen and fisheries are well represented. And then finally, my background's in research, so I do also stay connected to research. I go to conferences, I talk to scientists. One part of my role is to help develop our fisheries monitoring plan for Kitty Hawk wind that I'll talk about a little down the road. So we're going to start with kind of the overriding story behind both the story that I'm going to tell about the greentails and also for offshore wind. So climate, you know, it's changing fast is the bottom line. So since about the Industrial Revolution, which is where this figure goes back to, we've seen a rapid increase in the sea surface temperature around the world. This is kind of averages across the planet. We know that it's not, you know, it's not equal everywhere on Earth. And so I'll touch on in a moment just how North Carolina is actually a little bit unique in that story. But since about the early 80s, we've seen that increase in sea surface temperature rise about 3 times faster than it did in the period before that. So if you're a shrimp in Pamlico Sound, your environment is getting warmer. It's getting saltier because of the rising sea level. We're having more frequent storms here in North Carolina and around the world because of that increased heat in the ocean. And the pH of the sound waters are dropping. So this kind of brings me to my sort of driving force between why I was interested in looking at these shrimp and what they're doing here in North Carolina, and also how I ended up working for Avangrid and renewable energy. So as I mentioned, right, like a lot of times when we see big graphs like that, it's sort of the whole globe averaged into a number. The story in North Carolina is really interesting, and it turns out that North Carolina is a really pivotal region to understand climate change. And that, you know, most of us that are from here, we might be pretty familiar with this story. We've got warm waters coming up, kind of hitting the shelf edge in Cape Hatteras and kind of almost bouncing off out into the ocean. We've got cold waters coming down from that mid-Atlantic bight, and that really creates this really unique ecosystem. This is actually, that Cape Hatteras break is one of the largest climate breaks in the entire world. So, you know, this time of year in particular, that's easy to see, right? The wind changes direction, it gets a lot colder. The wind, you know, comes from the other direction, it's warmer. We're aware of that here as we're kind of poking out into the ocean. The rest of the country doesn't necessarily have that observation. And what that looks like in terms of water temperature, so this is just one day, back actually a couple years ago, but about this time of year, and you can see these colors indicate the water temperature. So red here, this is up in the upper 70s, lower 80s. Blue, this is in the upper 50s. So it's almost a 30-degree difference in temperature in a very short space of time. If you spent time on the water, you know, you've seen that real sharp front line. And what this means in terms of our species here in North Carolina is that you can have these warm water species kind of almost shoved up right up against that break, just waiting. If that cooler water gets a little bit warmer, they can kind of make that move, rather than in other parts of the country or on the coast where it's a more gradual progression. So this means we can see changes in our species assemblages due to that warming water really quickly. And that brings me to Pamlico Sound and the story of our shrimp here in North Carolina. So Pamlico Sound, as many of you are familiar, you know, we can look out the window here at beautiful Coastal Studies Institute and see it. But it's a really unique habitat, right? So it's very shallow. It's very protected from ocean waters because we only have just a few inlets. And it makes a really wonderful habitat for shrimp, fish, all kinds of invertebrate and vertebrate species, birds, all kinds of things call this place home and use it for really important migratory parts of their journey. So these are our 3 commercially important shrimp species, brown, pink, and white. And all 3 of them have this really interesting life cycle where they use Pamlico Sound for a large portion of their life, to grow, feed on the detritus or small invertebrates, and they also serve as a really important prey species for fish and crabs and all kinds of things, birds. So one really interesting part of the life story of shrimp here in Pamlico Sound is that their numbers can oscillate wildly year to year, right? We can see huge changes. So these are the commercial landings of shrimp in Pamlico Sound in millions of pounds. So the colors represent the 3 different species, brown, pink, and white. And you can see there's just these big swings, right? Where you have millions and millions of pounds, these 5-6 million pounds of brown shrimp one year, and then, back down to 1 million or even less than that the next. So this is kind of the driving force between this research that I'm going to talk about, is trying to understand what exactly is driving those big changes, right? Like, why do we see such wild oscillations? And part of it has to do with the life history of these shrimp. So they only live about a year, sometimes year and a half, but they have this really varied life history in that small space of time. So over here, we're going to show you where this one is. This is, out in the ocean. This is where shrimp reproduce. And then those post-larval shrimp have to make their way into Pamlico Sound. So they typically move into the very fresh habitats, the tidal creeks of Pamlico Sound. As they're very small, that's kind of the safest spot for them to find some habitat and hide in. And as they grow, they make their way down into the main body of the sound, where there's a lot of fishing activity that happens both in Pamlico Sound and out in the open ocean. And so they have to make this pretty big migration when you think about it for such a small animal in just about a year. And so to be successful, right, they have to evade being eaten, they have to find enough food, they have to grow, and they have to reproduce, all within about a year. They have slightly different timing that you can see down in the bottom when they do all of those things. So brown shrimp right now, we might be starting to see the earliest post-larval brown shrimp come in right about now. In the next month for sure, but probably those first few post-larval shrimp are coming in now. So this kind of varied life history compressed into about a year's time, that means if your environmental conditions are not what you favor when you're trying to come in and recruit as a post-larval shrimp, your life's going to be hard. You might not make it. You have great environmental conditions that are really favorable to growth and doing well, that population might boom and we have a lot of shrimp. So that's kind of the hypothesis behind this work, is trying to evaluate, what role do these environmental conditions have in determining shrimp populations? And, going into this study, we anticipated that the role of the environment would be big. That was kind of our hypothesis. And luckily, we were fortunate in that in North Carolina, we have 2 really amazing, what we call fisheries independent data sets collected by the North Carolina Division of Marine Fisheries. These are also publicly available, so other folks can use them or look at them. But they have a juvenile trawl survey they call the P120 survey that surveys in those tidal creeks around Pamlico Sound. That goes all the way back to the early 70s. And then a trawl survey through the main body of the sound that goes back to the late 80s. And so using these data sets, that was kind of the building blocks for this work, is knowing that we had such a long time series for looking at the shrimp. And because I was interested in evaluating the environmental factors, I also brought in a ton of environmental data from, again, mostly publicly available sources, but things like the North Atlantic Oscillation, water temperature and wind speed from NOAA buoys kind of posted around Pamlico Sound, precipitation from stream gauges, more shrimp biomass data from both the CMAP coastal trawl survey, so in those coastal ocean waters where you might see reproductive shrimp, and then the commercial catch within Pamlico Sound, and then of course all the environmental data that NC DMF collects when they do the sampling. So I had a lot of research questions. We're not going to go into all of them today, but one of them was looking at that recruitment of juvenile brown shrimp, because that P120 survey, they're picking up almost exclusively brown shrimp. The next question was just how many adult shrimp are there in Pamlico Sound each year for the different species? And then finally, what environmental variables influence how many shrimp there are. And so today I'm just going to be talking about white shrimp or greentails because we got a lot of topics to cover. We can't talk about shrimp all day. But this graphic basically shows the results of those numerical models that I built. And so you can kind of see you'll see the timestamp up at the top is the years. So starting in 1987 and going through 2020, you can watch kind of as these white shrimp sort of shift around and where they're distributed in the sound and how many there are based on the color. So there's a huge variety, right? Like some years they're all down south, other years they're pushed up north. And again, kind of, oscillating year to year how many we get. So this is that same map. So I took those basically, numbers of estimated shrimp by area and using, sort of a calculation of the size of the survey area that DMF does, came up with a number of shrimp for each species in Pamlico Sound each year going back to the late 80s. So again, these three colors here represent the predicted millions of shrimp. And you can see, here in the summer, we've got a couple years recently with large numbers of brown shrimp. Here in the fall, it's a little harder to see, but those white shrimp are really increasing in those recent years. So the next step was to take these estimates of how many shrimp there are in Pamlico Sound and figure out what's driving that in terms of the environment. So for white shrimp, which is the species I'm going to show you, it turns out to be a pretty simple story. So this number over here, this R² value, that basically tells us that we can predict 75% of the variation in the data using just two factors. And that's not to toot my own horn, but that is a little bit unheard of to have such high precision with only two variables. But what we're using here is this spawning stock biomass. So this is basically those adult shrimp caught the year before. And here are the north wind stress. So this is basically how strong the wind is coming out of the north in the wintertime. And with those two variables, we can figure out with 75% accuracy how many shrimp there's going to be the next year for white shrimp or greentails. But I started wondering a little bit, with that, you can tell from basically, you can tell from how on the left here of this slide, how most of these points are right around this line, that this spawning stock biomass is that's really the important factor driving this white shrimp. The wind is playing into it, but it's not quite as tight of a relationship. So that led me to thinking about what's really driving how many of these white shrimp are spawning off the North Carolina coast. And so looking into the environmental variables for that led me basically to find this really significant relationship with winter temperature. So when we have warmer winter temperatures in the water off of North Carolina, we get more spawning white shrimp off of our coast. And that results in greater numbers of white shrimp that end up in Pamlico Sound and in our fishery. And you can kind of see that here in this figure. So this is just white shrimp. The green color is basically showing you the years where there's a significant increase in the number of white shrimp compared to this kind of historical timeline. And so you can see in recent years, we ended this study in 2020, but in recent years, there's been quite a few years where we've had this significant increase in the white shrimp. And that kind of, makes sense with what we're seeing in terms of the fishery on the US East Coast. So white shrimp are moving north. Virginia, for example, never had a fishery for white shrimp. They opened one in 2017. Maryland opened a pilot program to commercially fish white shrimp in 2023. So this is kind of a rare example of where we're actually seeing the climate impact on a species that is commercially, economically, ecologically important in real time in just a few years. In many ways, this is a positive story, right? Because we all like to eat shrimp. A new fishery, that could be a good thing. But I think it's important not to sort of gloss over the sort of implications of this because we associate more shrimp with being a positive result because this is really sort of unprecedented in a lot of ways when we think about climate impacts on fisheries. So that leads me to my next topic, which is we're going to sort of make a leap in transition. But thinking about what those white shrimp are telling us about the climate, for me in my career, that kind of led to my role in renewable energy. And so we think about one type of renewable energy, offshore wind, and thinking about, why do we need offshore wind? What's the story there? And kind of the baseline here, beyond that the shrimp are telling us that this is something we need to think about, is that we actually just need more energy. So there's a recent study that came out, just this press release is just from a few days ago, really showing that the demand on the US electric grid is growing and it's going to continue to do so. A lot of this is driven, both by expanding population, increasing reliance on things like data centers, AI, ChatGPT, all those things suck up more energy than you can imagine, actually. It's a little scary to learn about it. So the bottom line is the United States needs more energy. I think, from my perspective, we need that energy to be both domestic and renewable. It turns out that we have, as you know when you walked in the door today, it's really windy here, right? We have a lot of wind. Wind offshore is more consistent and stronger than wind on land, right? Because it has that just space where it can gain speed and sort of stay more consistent. On land, we have a lot of cycles where, the heating of the land during the daytime will cause sort of fluctuations, cooling at nighttime. But offshore, the ocean is a fairly consistent temperature, and the wind speeds stay fairly consistent and strong. Building new energy streams is, in the long run, going to enhance the stability of our electric grid and also create jobs. So now we're going to focus in on North Carolina. I'm going to provide some information about sort of the offshore wind process in general, and then also talk about Kitty Hawk wind here in North Carolina specifically. But in North Carolina, just to kind of illustrate the process, so this is all orchestrated by the Bureau of Ocean Energy Management, or BOEM, and how they went about this process of deciding, who decides where we put a wind farm or what does it look like. That was all done by this Bureau of Ocean Energy Management. And what they did is first kind of start looking at areas where there was a lot of wind, had kind of, preferably sort of sandy, not too deep sediments on the bottom, and also had few conflicting sort of co-uses, so things like the military, commercial and recreational fishing activity, protected species, migratory seabirds, all these kinds of things basically led them to start with these big areas and almost like whittle chunks off, where it's like, okay, the Coast Guard says they need this area to be open, so we sort of slice a chunk off and remove it. So in North Carolina, we started with these fairly big areas, and they got whittled down to 2 areas off of our coast, Kitty Hawk Wind, and this area off of Wilmington called Carolina Long Bay. So the company that I work for, Avangrid, through a competitive leasing process, has won in 2017 the right to develop Kitty Hawk Wind. This area down in the south is split down the middle by Synergy Corps, so that's a subsidiary of Duke Energy, and then Total Energies holds the other side of that lease. So these are basically, when I was talking about, like, we start with these big areas, or not we, but BOEM, Bureau of Ocean Energy Management, and they basically take, everything listed here plus more, and use that to kind of do this spatial modeling and essentially try their best to come up with areas that, again, had sufficient wind speeds to make offshore wind commercially viable, and also had as few space conflicts as possible. So these are just kind of an example of some of the things that gets considered. I noticed earlier that actually military is not up here, but that's a big part of it. If any of you are familiar with DOD and that sort of government entity, you don't do anything that DOD doesn't want you to do. So that's kind of the bottom line. But all these metrics, bird and bat migrations, air quality, commercial fisheries, marine mammals, all these things play into it and go into basically carving off chunks until ideally you get an area that has as low number of conflicts as possible. And then So I mentioned that competitive leasing process. So for us with Kitty Hawk Wind, that was all the way back in 2017. And that doesn't automatically give a company the right to develop a project. What it does is it gives you the right to submit a proposal. And typically, this proposal, and the various permitting and steps along the way take about 10 years. Recently, that's kind of been extended, and to be frank, there's a lot of federal uncertainty at the moment that's causing some, we're not exactly sure what this process will look like in the future. Everything that I'm telling you now is, to the best of my knowledge, true. It's very possible that some of this will shift down the line. But basically, you start over here all the way on the left side of the screen with this leasing process. Kitty Hawk Wind is here, which makes it look like we're a lot closer than we really are. We still probably have about 9 years under sort of best case scenario before there's a fully operational wind farm. And really, this is, for the most part, this is a good thing that takes this process very slow. There's a lot of permitting, there's a lot of proposals, there's a lot of planning, everything from doing a fisheries monitoring plan, which I'll talk about, to monitoring birds and bats, and even the coastal permitting for bringing these cables ashore. Yeah, and then along the way, there's sort of technical reviews. And BOEM has the capacity to sort of either say, yep, this looks good, go ahead, or no, you need to modify this, or no, this is, we're just disproving this. So there's a lot of different outcomes. Just to give you some sense of Avangrid and what they do across the country, we have, I'm involved specifically with offshore wind, but the company is involved in onshore solar, onshore wind, some natural gas, and is even a utility company in some states. So they're not a newcomer to kind of both renewables and the traditional electric system. All right, I do have to apologize for the amount of words that are on this slide, but I wanted to make sure that if anybody wanted to reference this, it was available. So this entire area, this whole triangle, was what was leased to Avangrid in 2017. Just this last fall in 2024, we sold the northern portion of this, so where it's in gray, to Dominion Energy. So that is now in their hands. But the southern 2/3, that entire green area, is still with Avangrid, and we are planning to develop that project. So it's permitted currently to have up to 121 turbines. That doesn't mean that we will put 121 turbines. It just means that there can't be any more than that as far as BOEM is concerned. And the great thing about Kitty Hawk Wind is that it's a really soft, sandy bottom. There is some fishing activity out there, but to be honest, it's not a ton, right? There are a few folks that do some trawling out there. There's a little bit of sea bass potting and conch potting or whelk. But beyond that, there's not a huge amount of fishing activity, which is great. And this green area is predicted to produce, depending on turbine size, which might fluctuate based on market conditions and a few other factors, between 1.6 and 2.4 gigawatts of energy. Even though I work for an energy company, that doesn't mean a lot to me. So that's about 650,000 homes or businesses. To give you some sense of, these turbines are very large. They're very efficient. The blades can kind of taper into the wind to sort of maximize output. One turbine spinning once around fully, that's enough energy to power the average house for 2 to 3 days. So it's a massive amount of energy. Right now, Kitty Hawk Wind, we're at an interesting stage in the process, which is partially why this is great timing for this talk. But as of January, Duke Energy has announced basically that they're interested in the proposals from the 3 North Carolina offshore wind projects to look at acquiring that offshore wind power for the Duke grid. And so we're in the midst of basically preparing a very large proposal. I'm writing a couple sections, and it's ballooned to several hundred pages. I think it's going to get longer and longer. But basically showing Duke Energy, here's our plan for what it would look like to produce the power that they're asking for on the schedule that they're asking for, delivered to the locations that they're requesting. So that's kind of the stage that we're at right now. So they're interested in up to 2.4 gigawatts by 2035. So right now, that's kind of determining our sort of commercial planning and scheduling, is thinking about that proposal. And we will, check the news. We will hear back from the North Carolina Utilities Commission and Duke Energy by July 30th on sort of their verdict on these proposals. So it's an exciting time to be in offshore wind, to put it mildly. I'm just going to get a quick drink here.
We can't wait till our power bill goes down.
Well, I wish that I paid my electric bill to Duke for this purpose, Unfortunately, Dominion's getting my money.
Right. I don't think we're going to see that.
So as a fisheries ecologist, and a big part of my job is working with the fishing community, one point I always like to stress is really that these areas there's going to be no exclusions on any type of use. So you want to drive your small boat, your large boat, your cargo ship right through the wind farm, that's fine. The only rules are you don't touch the turbines, so you can get as close as you want to get, commercial fish, any kind of gear, recreational fish, spearfish. It's the ocean, right? We're leasing the area, we don't own the area. The turbines are going to be spaced about a nautical mile in each direction. So this is a diagram that shows to scale. This is a cargo ship, a 40-foot fishing boat, and an 80-foot fishing boat. So you can get the sense how much space there is. It also kind of stresses how big the whole area is when you think about it. But there's plenty of room to either transit through or fish gear. Cables, the inner array cables and the export cables will all be buried 5 to 8 feet below the stable seafloor. And that's in part, right, so that folks can use bottom gear, and also that these cables, that burying in the sand helps them stay, temperature stable. The only restrictions that are going to exist are for during construction, a 500-meter safety zone, like right around that active construction area. So not the whole lease area, just where there's actively like a foundation getting hammered in. And I'll talk a little bit more about this, but our expectation, as we've seen in other places, that you put structure in the water, that brings fish, right? We get mussels growing on those, we get worms, we get sponges, so turbines have a tendency to very quickly sort of turn into artificial reefs. So this is just kind of a not to scale diagram of what some of these components look like. So you've got your turbines, your inner array cables. There's an electrical service platform that sort of like bundles up the energy for transport. And then depending on the size of the project, 1, 2, maybe more if it's a really big project, offshore export cables that are, again, buried the whole way and then connect to land through a process basically called horizontal directional drilling, which sort of allows you to go under a beach so you can leave the beach undisturbed. And what typically we would look for a landing site is something like a parking lot where it's already disturbed and developed, and it basically can get the parking lot can get ripped up like you see here, and those joint bays are buried, and then with some access points for inspections and maintenance, it just goes back to being a parking lot. And this is what that looks like. So this is in Barnstable, Mass, where the Vineyard Wind Project is producing some power. It's not fully operational yet, but hopefully will be in the next coming months, we'll say, 6 months maybe. But these are those sort of access points for maintenance or repairs, but it goes back to being a functional parking lot. All right, switching gears slightly. So I'm going to talk a little bit about fisheries monitoring and how that will work for the project and how it's mandated to work across all U.S. wind projects. But basically, that Bureau of Ocean Energy Management and NOAA Fisheries have to approve a fisheries monitoring plan for all these different projects, and they require that you collect 2 years of data before any construction happens, data throughout construction, and then 2 years of post-construction data, basically to assess, how does the construction and operation of this project impact the ecosystem and the commercially important fish species. These are some pictures from, we've basically just this last year kind of kicked off our efforts to get started on that. We have a couple years before we need to finalize those plans. But this was a workshop that we had down at the Duke Marine Lab with both researchers, fishermen, guy from the Nature Conservancy, and a couple of the other projects. And then we had two meetings, one in Virginia Beach and one here in down the road in Manio at the library, to talk to fishermen about what species they wanted to see monitored and gear types they would recommend. So this is a big part of my role is designing this monitoring plan, and the process that I'm really committed to is getting a lot of input from both the fishing community, from researchers, from fisheries managers, both at the Southeast Fisheries Science Center and our local North Carolina DMF. Thinking about getting a lot of input, going through a lot of different iterations, and making those kind of ideas as public as we can. So I hope that those reports from those workshops we've already had will be on our website eventually. And there'll be more opportunities for folks to get involved and give feedback. So I have my business cards up here. I'd be happy to hear from anybody and can get you on our listserv to, kept informed about upcoming workshops. So what the researchers came up with when we met with them down at the Duke Marine Lab was a lot of different questions. And then after the fact, I kind of synthesized it into these 4 main ones. But we also had these folks, they were coming up with all kinds of ideas of things to look into. Towards the end of the workshop, we had them also rank a lot of those hypotheses to say, which is the most important, which is what do you care the most about? And so far and away, the most highly ranked question was basically thinking about this addition of turbines and scour protection. So scour protection is kind of this protective layer of rocks that goes around the base of each turbine. So that's natural rock, basically to prevent erosion from, eroding the sand around the base of the turbine. But basically, what do we see with that addition of structure? Does that increase marine species congregating? Are they coming from other places? Are we just concentrating them? Or are we actually creating more fish and more invertebrates? Next questions, kind of stemming, all going back to that, is basically how does that affect species movements, both on the big term, like climate-based migrations, as well as just really small-scale daily migrations of fish and invertebrates. Thinking about feeding behaviors, trophic relationships, how do food webs shift or not shift? And then last question here is how does that affect fishermen, right? So in a lot of places where we've seen these turbines get installed or artificial reefs get installed, we often see fishermen congregate to those areas. These are going to be, the closest point for Kitty Hawk Wind to land is 33 miles. So from Oregon Inlet, it's, I think it's about 45 miles. So, that's a bit of a run. It's a good question to think about, are we going to see, how quickly we're going to see fishermen respond or not respond, and what's that going to look like? When we met with fishermen, this is sort of the species list that folks came up with, and the kind of the seasonality and importance of those species at different times. We also talked with fishermen a lot about which gear types they would want to see used in a survey. So this is by no means a final draft. This is a very first draft. We're looking for more input. We're going to keep working on this. We don't need to have it submitted to NOAA for a couple years, so this is very much a work in progress, and very happy for additional input. But we do know from local wind towers, so these are the 2 towers that Dominion put out in 2020. They put out 2 small test turbines. So this is what they looked like shortly after they went in the water. And then just 2 years, you can see they're really covered with mussels in particular. There's some sponges and sea stars. So pretty quickly we see these kind of develop as artificial reefs. And I have on the next slide just a photo also. There's been a lot of reports of people catching smaller dolphin fish or mahi-mahi around turbines, amberjacks, some of those pelagics, smaller yellowfin. And then I do have this just quick video from Dominion that, sorry about the noise. But this is basically what it looks like, you know, a couple years after installation is really, you know, this, just like you would see if you put out an artificial reef, you get these sessile species, mussels, barnacles, growing on the surface. That brings in fish that feed on them. So, you know, our hope is that this project will be a good opportunity for fishermen, both recreationally, commercial, and the charter fleet. Okay, we're almost at the end here, but I did want to mention just a couple things about what construction looks like. So this is by far, you know, the construction phase of things. Of course, you know, we're still quite a ways out from this for Kitty Hawk. But you know, this is the point where you hear a lot about like this. There is quite a bit of noise produced, hammering these foundations into the seabed is energy intensive and it creates some noise. So some of the things that we do to mitigate that are use these bubble curtains. So basically, it's kind of what it sounds like, a massive garden hose. It's not a garden hose, but that's just kind of an analogy. Massive hose that goes down all the way around the foundation, and you just basically bubble tons of compressed air through that. And it creates like a sound dampening effect. And it can reduce, when you go up to that, even sometimes adding a second bubble curtain, it can reduce the noise up to about 90%. Certainly if there were, this is an area where, you know, we would love it if technology would find a way to even reduce that noise further. But it does work fairly well. The other thing that, you know, we're required to do, of course, is basically model how much sound we expect to be produced by this process, and then do a lot of what's called sound field verification. So get real-time measurements in kind of those first couple foundations that go in to essentially make sure that we're not producing excessive noise or that it's, you know, within the range of what NOAA allows us to do. So there's a lot I could say here. There's a lot of, you know, the construction phase is definitely the part of the process that it takes about a day usually to get one foundation in. So if you think about, you know, maybe up to 121 turbines, we for protection of marine mammals, we only do this when the right whales are not migrating through. So there's a no pile driving rule over the winter here. There's a bunch of other mitigation measures that we take to make sure marine mammals are protected, including third-party observers on the vessels at all time, kind of watching with all kinds of telescopes and gear, night vision goggles if there's any kind of night activity. And so basically all activity stops if there's any kind of marine mammals spotted. But I did just kind of want to show this because I think this is a good illustration of how the bubble curtain works. And then really kind of the final note I wanted to make is that on that topic of marine mammals, there's just a huge amount of misinformation, disinformation, and, you know, to be fair, some things that we don't, you know all the answers to, certainly, about offshore wind and whales. And so I think this is one area where, as a scientist, I'm not someone who is a marine mammal expert, but I've certainly learned a lot more about them in recent years. Just to stress to the public as much as I can, you know, trust scientists on this, trust conservationists. Try not to share things on social media that are of questionable origin. But this is a really great paper that's publicly available that'll come right up if you Google it. It came out February 2024. But basically, you know, we are in the midst of this, what's called an unexpected mortality event for humpback whales and right whales. Humpback whales, part of the story with that, and another good local source for information is a couple great professors down at Duke, actually, Andy Reid and Doug Nowacek, who are both really active in kind of trying to spread the correct information. But humpback whales, really, their population is actually expanding, which is part of the reason why they're increasingly, unfortunately, ending up in shipping lanes and often being hit by vessels. The other part of the story is a real increase in vessel traffic. So this is complicated. I'm happy to talk about this more in the questions section, but did just want to get it up on the screen. So finally, thinking about what do greentails have to do with green energy? As I mentioned before, we're seeing this rapid movement of the population of white shrimp up the coast, new fisheries, new areas where these shrimp are moving into. And really, I think what that tells us is that we're seeing climate impacts on our fisheries now. We're not, when we talk about it, some of these things are going to take longer to measure, but with shrimp, it's not, right? We know, we can see this marked by these fisheries opening in Virginia and Maryland, where they've never had them before. So green energy is not the whole part of this solution, certainly, but it is part of it. So for my role with Avangrid, I really view this as an opportunity for us to develop green energy responsibly, to really prioritize coexistence of these projects with local fisheries, and also, not just think about coexistence, but also think about how we can enhance fisheries and ecosystems and provide opportunities for fishermen. So that's kind of my perspective on my role with Avangrid. And here's some ways to get a hold of me and find out more about Kitty Hawk Wind. And I'm very happy to answer any questions that you might have.
Thank you, Lela. And so this is being recorded. It's also online, live. And so if you could just ask your questions into the mic.
If the shrimp are moving north, what's happening to those southern fisheries?
It's a good question. There are reports that in Georgia and South Carolina, they're seeing decreasing catches of white shrimp. They've certainly been on the decline. There's other potential reasons for that. So it's not quite as clear-cut as the whole population is just shifting north. But I think, a few more years of data, we might have a better understanding of that, but it certainly seems like it. So, right now, it's been a big benefit for North Carolina fishermen to have these greentails in greater numbers. But we do also have to think about, another decade, maybe they'll, their main base will be Virginia and Maryland or further north. So right now we have abundant shrimp. Brown shrimp are still kind of doing their normal up and down, it seems like. But yeah, with the white shrimp, it's hard to know what's going to happen in the future, but it points towards, yeah, certainly decreasing numbers in their population down south.
So the coast of Scotland has had wind farm energy for a long time now. What kind of research has been done to look into the long-term impact on the fishing industry there? And I have another question.
It's a good question. So I was actually in a meeting this morning with a researcher in the UK, talking about that very thing. They have a lot of different rules and regulations about their wind farms. So they're often surprised when we talk about how long it takes us to develop and build them, because they had a much faster process that didn't particularly prioritize research, which is not to say that research hasn't been done, but it was never mandated for each of these projects like we are doing in the United States. So while we've seen kind of a lot of those similar patterns of kind of that I talked about that we might expect of kind of artificial reef effects, we don't have as many of those big picture studies on ecosystem effects from those wind farms, which is unfortunate. The other thing is that, because really species assemblages are pretty different between different places, sometimes when there is data available, you don't necessarily want to draw that conclusion. Like for us, like having the Virginia turbines is such a big asset because it helps us understand what's going to happen here likely. Whereas, even some of the projects in New England, really different species assemblages, things like lobster, bigger squid fisheries. So there's kind of just different focus on the research. But yeah, unfortunately, what we know we see that kind of artificial reef effect on those UK projects in Scotland. We don't have a lot of those big studies done like we will in the United States. What we do have, the Block Island Wind Farm, which is off the coast of Rhode Island, that was the first project in the United States. It was built in just before 2020, I want to say. They have now, it was finalized in 2018. So they have 7 years of data now and just came out with a study showing increased numbers of black sea bass, lobster, and I think no change in the squid around that project. Yeah.
Second question. One of the slides said the Kitty Hawk wind farm would provide power or energy for 650,000 homes. Is there a plan as to where that energy is going currently, or is that still being developed?
Great question.
And are we going to get some down here, or is it all going to Raleigh?
So, yeah, so the proposal that we're working on right now, which for the moment is kind of the commercial path for Kitty Hawk Wind, would be to go into the Duke Energy grid. So they can then distribute that throughout North Carolina and even into South Carolina. Here in the Outer Banks, as many of us will know, we are on the Dominion grid. The Dominion has now 3 offshore wind projects, one currently being constructed, the other 2, further down the pipeline. But we will likely, be receiving energy from that first wind project when it's done in just a few years.
A shrimp question. I know we've had good catch rates here. I'm not a commercial fisherman anymore, but the last few years, you had data up to not the last few years. Is there any, I know they're not threatened, white shrimp, and they produce 500,000 to 1 million eggs per shrimp. Does the large catch rate affect the biomass entry into the sounds?
So if we're talking about catch rate out in the ocean, so it doesn't seem to. Right now, like a lot of what my results showed were basically that, the environmental variability drives those population changes and how many adults were out spawning. But if more people, they're catching more, there's clearly going to be some link there between, but it's hard because they're an annual species, so there's less of a link between the fishing pressure and the population next year. So a lot of them, even if they're caught, we hope that maybe they're reproducing before they get removed from the population. And the state doesn't really set a quota on them, right? They're just however many we get, that's however many we get each year.
Where are the cables going ashore for the Kitty Hawk Wind Farm? And where are the substations located, and what are the square footage of the substations?
That's a good question. I will have to get back to you on the square footage of the substation. If you want to take one of my cards, I'm happy to find that out and email you. I don't know that offhand. The cables so the proposal that we're working on for Duke Energy, they have mandated that point of interconnect for those cables be in New Bern. And so the cable route that we are considering most actively, I guess I would say, or have the most advanced engineering on, is an oceanic route that basically goes down all the way to Atlantic Beach and comes ashore in Atlantic Beach and then makes its way by land up to New Bern. So that is quite a long route. There are challenges in North Carolina with connecting to the grid. You basically need a substation that can accept the volume of energy that you're producing. And for us, the closest point in North Carolina is actually New Bern, which is surprising. So we can't come ashore here because there is not a substation able to accept that volume of power, basically. A shorter route would be to Virginia Beach, which is still a possibility. But the more active route that we're considering is to stay within North Carolina and bring it down to Atlantic Beach. Yeah.
You said Dominion purchased a section of that land from you guys. Is Dominion also planning to sell that back to Duke, or are they going to be routing it north up to
Heck no.
their stuff?
They're going to sell it to themselves. So that is the unique challenge here, is that we've got two states that have energy monopolies, right? So Virginia and Dominion, and Duke in North Carolina. So yeah, Dominion being a developer, it is also the utility. They're going to sell that power to themselves, likely in Virginia Beach, although I don't think they have the approval for landing the cables yet. But yeah, stay tuned for that. I think their focus, I'm assuming right now, is on continuing to build their CVOW project, which is, yeah, right off of Virginia Beach, and already has their landing, their cables are already installed.
Other questions?
Yeah, more statements than questions. First of all, depending on the North Carolina Division of Marine Fisheries to come up with accurate data is fool's folly. I've been involved in it. I've seen the deterioration of it to the point now where there's absolutely zero trust by fishermen in any science that's gathered by the North Carolina Division of Marine Fisheries. Secondly, you're kind of pawning off the issue of just say pinnipeds in general. You're talking about humpbacks and you're talking about right whales. Of course, we're very involved in that too. I'm a fisherman and I make my living in the ocean. And there is a direct correlation between the sonic booming and the death of not just right whales and not just humpback whales, but finback whales, pilot whales, every kind of dolphin and porpoise. I have seen them. And it's a direct correlation with the ship that's out there sonically booming, and it's the same way the entire coast. I have a very pessimistic view of how this particular, the most expensive energy there is, and the destruction that happens on the floor, and the fishermen that I know that pursue their living in these wind farm areas that have been devastated. I mean, you talk about, well, conchs, no conchs. You talk about all of the rest of the bottom dwellers that typically have been very prevalent in some of these areas that have vanished. They've disappeared. So forgive me for kind of raining on your parade, but they're the facts that I see, that I know.
So I appreciate your comment, and this is, I'll point out a couple things, I guess. One, the sonar that we use basically to survey the bottom is because what differentiates us from like oil and gas developers is that we don't really need to know what's going on below the sediment. We need to kind of map that sediment and get a sense for, is there rocky bottom here? Are there clay particles here? We don't really need to know, like when oil and gas does their kind of discovery, they use really deep sensing technologies like those sonic booms. We actually don't use that technology. So most of what we do to map the seafloor is, essentially what's on commercial fishing boats, like a fish finder, basically to do side scan sonar. And I'm trying to remember some of the other points I wanted to make, but yeah, so with regards to the marine mammal stuff, the unexplained mortality event for humpbacks goes back to before there was any offshore exploration for wind farms. That one paper that I pulled up, I wish I had time to really go through kind of the whole thing with it, but what they do actually is they look at all of the sonar activity and all of the construction activity that's happened in the US to date and try and see if they could correlate it with any marine mammal mortality events. And their conclusion was that there is no link, that when we see these whales washing up on the beach or floating offshore dead, it's not at a time when any of these companies are actually doing any kind of exploration or construction. There is not a link there. There is, I don't want to diminish this unusual mortality event. It is very serious, right, that we're seeing these right whales. In particular, their numbers are quite low, just about below, I think, 350 now for the population. And the humpbacks, as I mentioned, Doug Nowacek down at Duke University, who's a marine mammal specialist, he's studied them for probably 50 years now. Basically, this population of humpbacks is growing. And so we're finding them more frequently in these areas of shipping lanes, in part because the population's expanding, and in part because their food sources are moving into these shipping lanes, in part because of climate change. So while I'm not going to tell you, that this pile driving that we do, right, that is a stressor. Like, as a marine scientist, I'm never going to say, no, that's no problem. A lot of marine animals use sound. What we do, though, is the data doesn't show any link between offshore wind and whale deaths. And the number of mitigations that the offshore wind industry is, the list is long compared to what any other marine business or shipping does. Like, for example, any of our survey boats, construction boats, anyone that's doing any work for us, they're not going faster than 10 knots. That's a rule. Your cargo ships coming with all of our Amazon ping pong balls and sunscreen and whatever other crap we're ordering online, they're not restricted to 10 knots. What we know from the science is that going slow and having spotters, which we do have these third-party independent spotters on these vessels at all times, that allows them to kind of spot marine mammals and basically radio that the boat needs to disengage and stop right away. So, understanding what's going on in the ocean, like, I'm always grateful for fishermen's on the water experience and knowledge, like, because what you see with your own eyes, that's like, I don't want to diminish that. But the big picture here, and I would encourage everyone to kind of Google these authors and this manuscript, is that we don't have any data showing that there's a link between whale deaths and offshore wind, whether that's kind of the sonar aspect of mapping the seafloor or the construction. There is what there is. I will stop now because I don't want to drone on too much, but there is actually evidence in several publications that have come out of universities showing that there's a link between that sort of story of offshore wind and whale deaths and the oil industry. So we know that a lot of those studies, or not really studies, but social media campaigns or whatever, that's been funded by big oil to sort of disparage green energy.
Y'all have a lot of permits to kill a lot of mammals.
We don't have any permits to kill any mammals.
BOEM does. That's what I wanted to ask. BOEM has a permit. I've seen it online. NOAA has granted them a permit. They can kill over 2,000 whales. 2,000. So I just want to know, is that for just the seismic?
No.
Or do we get to
So there is a bit of a confusion because there is a terrible name for the permit that we get to basically do our sonar work, where we are basically allowed to emit a certain amount of noise that is tightly regulated by NOAA Fisheries for these sonar surveys and for the construction. It was a bad idea. They decided to call that a take. In no way does that indicate.
And how many? And
but it is in no way. So it is no way a permission to a take. A take means expose a marine mammal to a certain amount of noise that they call, basically might cause it to change its behavior. Not death. Absolutely not. No, not death. No. So they call it, there's level A harassment and level B harassment, which are both, again, terrible terms. And these are what they call the takes. Terrible terms. In no way indicates that any marine mammals are allowed to be killed. But what that says is basically that level A is I'm going to forget the definition, but level B, I think, is this amount of noise might cause a marine mammal to change its behavior, and level A is slightly greater than that. I can't remember what the distinction is. But it in no way is like a permit to kill marine mammals. That level B harassment.
They really messed that
They really messed that one up.
I mean,
They really messed up.
And we're like, a harassment permit.
Yeah.
Why would you grant a harassment permit?
Right. And all that means is,
Here's the other problem, which I want to tell you. Like, I know I'm not a scientist. Oh, I'm not a scientist, and people say respect the science. But like, here's the challenge. These survey boats, these seismic, we've been watching them up the coast. They have AIS on them, correct? You see them leave the dock, you see them come back. They're tracked. And yet, every time they go, there's more dead whales. And I'm talking like 200. I'm not just talking about humpbacks, dolphins. I mean, every species. And I'm
curious where there's 200.
I can show you this Facebook group. You got to see it. It's amazing.
That's what I'm trying to say is don't believe what's on Facebook, right? Like,
well, like don't believe citizens like me who post. Like I've been born and raised here.
Okay.
And I've seen more dead whales than my entire lifetime. And you're just like, oh, there's more humpback whales. And I'm like, what about the dolphins? Okay, I mean, these fishermen in here are seeing them. They're belly up. That's what's floating that's what's making it to us. And so it's really hard that you say, seismic vessels are out. We're watching them seismic test. Hey, guess what? Within a week, you've got a whole splash of dead, like citizens posting dead animals. People like me posting them on the internet and saying, that's AI. I mean, it's just really like, it's hard to go, and you have a harassment permit. You were going to emit these signals, but they're all good. Everything's fine, and this is harmless. When the conchs are gone, when the scallops are gone, when the fisheries, like, what happened to them? But they left with the same time that you see the seismic testing. So that's really a challenge for us to say, oh, please trust me. Please trust the universities that, Duke Energy and Duke University, I mean, you're like, they're not the same, but they're funded. They're paid. You are paid. You are paid by Avangrid, who is going to sell energy. I mean, I'm here for it. I love capitalism.
well, so
I mean, it's just like, it's really hard for us to be like, what about the stuff that's not the way?
I don't want to discount anything that you said, but I do want to just point out that it's been, I think, 3 years since we've done any kind of, sonar work on the seafloor. Same for CVOW. So, if there's dolphins that are, washing up that I'm not aware of that, but there's a lot of other things that could be causing that. And I think,
where they're doing all this stuff up, like the whole, we're just next in line.
But again,
and as they got close to here, you watched them. They went out of the Virginia area, and then all of a sudden they're in Kerala. They're in, and you're like, oh. Like, we could predict it. Like, I could tell you when there was going to be a dead whale. And I started, because I was the one on Facebook being like, hey, watch out, the seismic people left, and then within a week, you got a lot of dead whales and dolphins and everything washing up. That was all ship strikes.
So a lot of times when, NOAA Fisheries, right, they do these necropsies of dead whales. Obviously, they probably can't always tell what the cause is. But when they can, overwhelmingly, they're seeing ship strike evidence. They're seeing entanglement in gear.
Would you say that their communication is that they have to communicate via sonar? And so if they're just jumping in front of, I mean, what's crazy is they've missed these ships all these years, and all of a sudden.
The technology that we're using, though, is really akin to like a fish finder. It's really, we don't do anything on the scope of what oil and gas does. It's a completely different set of.
Have any oil and gas off our coast?
There is not currently.
Oh, okay, I was just wondering.
No. Appreciate all these comments. I do want to mention that my card's up here if anybody wants to grab it for after the fact.
A real quick question.
Yep.
It has to do with maybe this study, but other things. Only because we have a good friend who studied this through the Army Corps of Engineers, looking at the effect of naval vessels.
Yes.
Their sonar.
Yes.
On.
And that's a great point because
on the sea mammal death. So did this study include any of that data?
So this is just in the recent year, and so in recent couple years, I think it goes back to maybe 2017 when offshore wind activity was, in its infancy in the United States, but just starting. So those like naval blasts, that was basically, that goes into the data. So when I talked to like Doug Nowacek, who's that marine mammal expert, basically what he told me is like, that's how we learned a lot about like what whales can hear and what levels are bothersome to them. And so that's the information that goes into our permitting to say, we're gonna make this much noise, and that is, way down here compared to what we know is bothersome to them. And so that's kind of the data that goes into like what NOAA Fisheries says, you know, you can emit this much noise, you can make, you know, you've got to, if we're going to go and measure how much noise you're producing when you do that pile driving, and if it's not within the levels, like, you're done, right? You've got to find ways to get that noise down to the levels that they say is fine for marine mammals, or that might cause them to leave the area, but is not going to be more stressful than that.
So the comparison of the levels that you're allowed, the comparison of the levels that you're allowed, are there the same restrictions and comparisons for the sonar from naval vessels?
They have different permits always, right? Like any kind of defense activities, they are allowed to, they have a lot more leeway. Let's just say that. Yeah. I think that following that incident that you're referring to, you know, they've restricted them somewhat, but.
Well, I mean, it wasn't just that particular incident. I mean, what our friend did is he tracked activity all over the world, and the sonar and some of the communication that was happening with naval vessels and looking at sea mental health.
Yep.
And so I guess my question is, as we're looking at this, are we looking at a comparison? Are we looking at this is the ant versus the elephant?
Exactly.
And it's not that the ant's unimportant. And
Right.
It's not that the elephant can be done away with.
Right.
Because I'm just trying to think about the bigger picture.
Yeah.
Of what could be contributing to these deaths.
Yeah.
How the regulation is it consistent across the board, and understanding that there are trade-offs.
Yeah.
You know?
I think, you know, I can only really, my assumption is that any kind of naval vessel, Department of Defense, they have a little bit more leeway. But, you know, for the offshore wind industry, we're tightly regulated by what NOAA says is permissible, and what they, you know, have used data to basically say, we don't believe this level of noise will be harmful for marine organisms.
Thank you, Lela. We appreciate it.
Thanks, Reed. So information up here, happy to talk, and thank you.